Hi, I'm Eugene, and we've built over the year the video player in Zalando based on React Native, and I would like to share our experience. I worked before Zalando as Android engineer in Southeast Asia, Super App in Grab, and in Middle East in Kareem. Before we started migration in React Native, I was able to see how was looking architecture on for video player. It was something like that. As you see, we had two applications for two platforms and SDUI backend. So SDUI was needed as part of our business requirements. So we needed to make sure that we can do updates on the client from backend. And the main problem that we had that time, it was the state problem. Because we needed to synchronize the state on the backend and state in the app. Video player has quite complex logic, and a remote state is not so easy to synchronize. React Native somehow solved this problem because we can just keep all logic on backend and then update the client over the air. And the solution came from above. Actually, we didn't plan to do migration, but the whole Zalando decided to do that, and it was exactly what we needed. These are main migration approaches that we decided, that we estimated that time. First is third-party library, of course. We can just use the existing React Native video player and just integrate it in our application. The problem with that there was many. It's a specific third-party library, very popular in React Native community. It has a lot of features, but most of these features we didn't need, and we didn't want to support all these also platforms that we didn't need that time. Also, we found some issues initially, especially there was old architecture that was not a choice for us. We wanted to build everything on the new architecture. This was actually one of the motivations for us. This new architecture, and it was a motivation for us to move to migrate to React Native. The other way to solve the problem is just to wrap the component, the existing component that we had in React Native, the existing component on every platform that we already had, just wrap them into React Native component and provide it. But of course, we didn't want to fast integration, but we didn't want to solve all these possible problems that I already shortly described. When we already delivered the app, we needed to support and commit to this stability and functionality that actually we already wanted rather to the rewrite from scratch. We thought also about other multi-platform approaches or cross-platform approaches, but let's say content multi-platform is very close to our experience. We were native developers, and it was quite convenient to use this technology. But the problem is that we would not have long run over-the-air updates. And also we would not get the support from our platform team. So what should we do? Just write everything from scratch. We created Fabric component for video. We have full control. We can use new architecture. The only thing we need time. This is how we approach the component architecture. So we had the native layer, video player, Fabric component itself, implemented in two platforms, Android and iOS. Above it, already in React Native, we had ZDS video component layer. ZDS is Zalando design system. It's a presentation layer, which we potentially can switch to other presentation layer, to other view system. And most of the logic we keep in video component. Video component is responsible for API and most of the features that we have. We initially decided to keep some features out of the scope. As I already explained, we needed to build component for Zalando. So we are bound to a specific domain. We know our consumers. We didn't need DRM, background playback, or anything like that. But from the other hand, we could actually put everything in our component that we know for sure that our consumers would need, like analytics, performance tracing, and so on. The idea was that our consumers can just plug in our component and it just works. If they need some customization, we have very flexible API and they can do everything they want. This is a video stream screen. This is our first screen that we've built with our video components. It provides immersive experience for videos. It has a list of videos. All they are full screen. Other options, and it can be accessible from different parts of the Zalando app. The idea behind it, that in Zalando app, we can have entry points. Probably small, most of the time small videos, which when user click them, they get to this immersive experience and they can spend some time on the screen. Also interacting with products that are related to these videos. So this is the functionality that built in several months already, except maybe accessibility, because accessibility is very hard to solve. It's almost parallel development, and it needed a lot of time. As I already said, we included there everything that our consumers could need, like analytics, performance tracing, subtitles, error handling, autoplay. This is a feature that when playback triggers on visibility. This is also not hard to solve. We needed to implement or use the platform callbacks in order to start it. The idea behind it that when video becomes visible, and visibility should be set up, like 75% or 50%, we start playing. And now we have our first consumer. This is home feed. Home feed have this so-called entry point videos. As you see, they lead to video stream screen. But as you see, they are. Let me play it again. As you see, they are small videos. It could be played in the same time, several videos, 2 or 3, and there are many videos loaded also by flash list in the same time, and they are in memory even if they are not visible. This brought us a lot of performance problems that we had to solve. Jerky scrolling, white areas, and memory pressure, because we had many players in the same time in the memory, and some of them were loading. How we can start performance investigation? Of course, first we have to define metrics. Our classical video metric is autoplay time. Autoplay time, this is the time when between the two states when video becomes visible and between the first frame of video. What it actually means that first the user sees thumbnail, just image, and when it starts to play, the user sees the animating video. So it actually can trigger interactions. User can start to interact with video, can click through it, and do other actions. That's why it's related to business metrics. So it's very important metric. Other metric that we can use is classical FPS or jank. And this is exactly what suffered mostly on home feed. I have chosen to use jank. Jank is a share of the frames which is discarded by the system, which are not rendered, and this is directly related to smoothness of UI, especially scrolling. Also, of course, we need some memory metrics, and the memory metrics we can just use the number of players. For players, we figured out that for Android, this maximum number of players in memory, playing or loading, it's quite limited. Much more limited than for iOS. That's why most of our optimization were on Android. Of course, we started with rendering issues. This is a classical React Native approach. We use React Native profiler, find the renders count, then try to decrease it. Merging states, code reorganization, memoization, of course. Making sure that our throughput between native and React Native world works correctly. But this didn't solve for us the issue. This was the solution. Lazy loading, I would rather call it lazy creating, because actually the idea is that we are creating the player on the fly. When user already sees this, when user, as you can see on the scheme, on 75% of visibility, thumbnail becomes video. And this is what we do. This looked for us initially counterintuitive that this dramatically can increase the performance, but because we create the quite expensive component on the fly before users' eyes, but it solved our issue. So we had improvement for jank rate, 24%, percentage became 3%. So we got the smooth experience. But we had to pay for it. We paid with autoplay time. And I already said that autoplay time is very important metric, business related. That's why we had to do something with this. Autoplay time increased almost to 2.5. And we needed some radical solution. These many approaches that we took. The first approach is video thumbnails. The idea is here that we already became cross-platform developers. Why not become full-stack developers and think out of the box? The best solution was actually to change this on backend. We added new transcoding job, MP4, and with normal format that we had, HLS, we recreated MP4 specifically for video entry points. This was 5 seconds videos in MP4 format, which are easily loaded, very quickly played, and cached properly. As you see, this decreased our autoplay time by half. The second optimization that we did is first video tile loading. This prioritization, this is specifically for video stream screen. We have GraphQL, and for us it was quite trivial to split our request to 2 requests. First is loading what matters most, and the second loads everything else. So we just load visible part of the screen and then everything else sequentially. This already increased our autoplay time for the first video very substantially. The next optimization is a player pool. The player pool, the idea is that we can share several native players. For Android, it's exoc players in memory between different instances of video player or fabric component. So when we create new video player component, we can just reuse previous player, and also for Android we can reuse its codecs and buffers. Most our screens, they actually have the same format of the video. So for every particular screen, we can share most of this setup. This didn't improve our autoplay time so dramatically as other optimizations, as you see. But the idea of player pool actually is much more interesting because we can use it for different other optimizations. Let's say pre-warming. If we need to implement some pre-warming, if need to create the players before user sees them, if we can predict the user's actions and know which content the user intends to see, to watch. We can just create it and put it in the player pool. And yeah, it can help then optimize the experience when user actually do an action that will predict, watch the video, and the video is already there. This is much harder to do, especially predictive pre-warming. We already freed up the resources using lazy loading. We have only several players in memory in the same time. Of course, we can focus on specific use cases when we know exactly what users want to watch. But the easy part is initial pre-warming. When we actually already know when the user lands on the screen, we are able to understand which videos the user intends to watch. And we can pre-create them, pre-create codecs if needed, or use the whole content. Before to wrap up, I would like to say that for me, I'm a native Android developer, and for me to work with React Native was quite surprising. We had many native developers have this bias that there are some problems that are not easy to solve with cross-platform technologies. But our journey proved me wrong. Actually, I think that it's quite exciting to work with React Native, and I'm interested in what we can build next. Thank you.